Hello, everyone. Welcome back to another session on statistics. We're almost done with the descriptive statistics. We're gonna move on to inferential statistics soon. But before I start talking about inferential statistics, before I start talking about the formal statistical test, I'd like you to know some of the concepts which could be very useful, which could help you understand all those statistical tests I'm going to talk about. So this session, I'm gonna review some concepts which could help you understand all statistical tests. Well, these are the objectives for this session. So at the end of this session, I expect you to be able to distinguish different types of variables that you have in your study or in your research. I expect you to know the concept of normal distribution and how it could be useful in statistical analysis. I expect you to know what a hypothesis is, how many different types of hypotheses we have, and generally speaking, the hypothesis testing procedure in your research. I expect you to know different types of statistical errors which could happen during your research. I expect you to know the two main types of research design. There are different classifications, different categories, but here I just came up with a very simple classification, which later on will kind of refer to this classification a lot during the uh, statistical analysis or during the inferential statistics sessions. And at the end of the session, this session I'll talk about two different classes of statistical tests, parametric tests and non-parametric tests. This classification would kind of help you to decide better, uh, like which type of statistical test you need to use. So it's very, very, very helpful. Well, the first concept I'm going to talk about is sample and population. Um, I like to start with an example. Like, for example, imagine you have a research question which is about like Cantonese speaking kids, like kids between the ages of like 3 to 5 years old. And you're interested in uh, seeing how these kids learn a new language, how these kids learn the new words in a language. So uh, basically, I don't think that you can go and like recruit all the kids at the same age range in Hong Kong or in other areas in the world where Cantonese is spoken. So you just need to find some kids, like a handful of kids, and start working with them. So this handful of kids you're working with in your uh, research is called sample. Sample is a collection of participants with whom you're working in your research project. But this sample is kind of uh, selected from a bigger population. So all the kids who speak Cantonese, for example, in Cantonese as the first language in Hong Kong, that's the whole population. So if you want to do a research study on these type of kids, definitely you can't go and work with the whole population. So you need a smaller sample, which makes your research more feasible, can do it more easily. So you need a you need sampling. You need the kind of a sampling strategy. Most of the times people uh, revert to resort to a probability sampling, usually uh, through random sampling. They randomly try to select a participants from the bigger population and then form a sample. Once you have this sample, and then you have a research question, and then you have your own hypothesis, you kind of design something, you collect data from this sample, and then you analyze your data, and then at the end of the day, you want to draw some conclusions about the bigger populations. You want to make inferences about the bigger population. You want to generalize your findings to the bigger population. This part is all about inferential statistics. This part is all we're going to talk about later on, like when you have data from a sample, when you start analyzing it, and then we want to see whether we can generalize our findings to the bigger population or not. So something which is very, very, very important here is sampling error. So uh, basically, we have like individual differences. Like we have so many different types of variability, which um, like good variability and bad variability, which could result in sampling error. So the lower the sampling error, the better the inferences could be, because once the sampling error is small, is very low, that means that what we're seeing in our sample, we could also see the same pattern in the population. However, when the sampling error is high, because of any reason, because of the way you selected the participants, because of the way you did the statistical analysis, once the sampling error is high, then the results of your study cannot be very reliable. And at the same time, you might not see patterns in your sample because the sample is not a representative sample uh, for the population. So so we talked about sample versus population. Population is the bigger pool of the participants, and sample is the collection of the participants you're working with. Well, let's talk about different types of variables that you could have in your research. So there are there are two main variables in every type of research. We call them independent variable and dependent variable. A dependent variable also has other names such as outcome variable, such as response variable. So once you hear independent variable or response variable or outcome variable, these are most of the time used kind of interchangeably. So these are not different variables, but they all convey the same concept. So independent variable is something that you manipulate, you change in your study. But the dependent variable, on the other hand, is something that affected by the changes you make, by the manipulations you make in your research design. Like look at the photo here. So imagine uh, adding different doses of fertilizer is uh, is the independent variable. Like we want to see whether adding different doses of fertilizer would have any changes on the growth of the plants and vegetables or not. So in in one pot we add no fertilizer, and in one pot we add 2 drops, 4 drops, and 6 drops over a month, and then at the end of the month we'll see which of the plants has had the biggest growth. So in this type of design, our independent variable is the amount of the fertilizer dose we use, and our dependent variable is the growth of the plant, which we could measure by different techniques and strategies. So I'll give you another example in our own field too. Like, imagine again we are working with people with aphasia, and then we're having like 3 different types of treatments, and then we want to see which one of the treatments results in the best performance when it comes to like pragmatic skills. So our independent variable is the type of treatment we are using. So it's something that we manipulate, we make changes intentionally, and our dependent variable is the pragmatic skill, which we could measure with a test. So we want to see whether any of these treatments would result in better pragmatic skills or not. So you could easily see that on the one hand, I'm making some changes, and on the other hand, I'm trying to see whether I see the changes in the dependent variable or not. But that's not all of the story. So in every research design or research study, we also need to uh, control many other variables. Like, look at the example of these plants or the fertilizer study. It's not only a fertilizer and a plant. You need to control for so many things in the environment. For example, you need to control for the amount of the light these plants are getting. So we have to make sure that all of these plants are getting the same amount of light. If one plant is getting more light than the other ones, and at the end of the uh, experiment there is a difference, how could we be sure that this difference is because of the fertilizer, not because of the light, or the other way around? So that also applies to any kind of research context or research setting where we need to control many different variables so that the validity of our study is not under question. Um, I think that I've talked about the scales of measurement. I've referred to scales of measurement several times during uh, sessions and this descriptive statistics, but in this session, I just want to briefly talk about them again so that uh, we kind of agree on the definition of on each of these scales. So generally speaking, we have several types of scales, but I just put 3 of them here. These 3 scales are the most popular scales in our field. So we have nominal scale. Nominal scale uh, is kind of uh, categorical in the sense that is more like yes and no, is more like gender. It's not doesn't come from a test, or it has nothing to do with the score. So it's mainly with a categorical nature. And then we have ordinal scale, which is basically you could also see from the name is ordinal data, such as rankings in a race. So we have someone who ranked first, someone who ranked second, and someone who ranked third. Uh, like, imagine in a running race, like someone um, is the first one, someone is the second one, someone is the third one. The thing is that we just do the ranking here. The difference between the first person and the second person, the time difference between these two ones might not be equal to the difference between the second person and the third person. So the second person might finish the race after like 1 second after the first person, but the third person might finish the race like 5 seconds later than the second person. So the differences are not very equal. That's why it's ordinal scale, it's not interval scale. An interval scale is continuous, is a score. So if we have like from 1 to 10 on an interval scale, the difference between 1 and 2 is exactly the same as 2 and 3. Or the difference between 3 and 4 is exactly the same as 4 and 5. That makes it interval scale. That makes it different from an ordinal scale where the differences or the intervals are not equal. We also have another scale called ratio. I'm not going to talk about it, but it's just like interval scale, but with an absolute zero. Um, Normal distribution is the next concept I'd like to talk about. It has other names too. The bell curve. Uh, they call it the bell curve because it has a bell-shaped curve. Or some people call it Gaussian distribution, but normal distribution is the most popular concept many people would prefer to use. So uh, the cool thing about normal distribution is that, I mean, we have talked about it several times in the previous sessions, but the cool thing about normal distribution is that if you get to know the mean of the distribution and the standard deviation of the distribution, you can do many, many cool things. I mean, we already know that normal distribution is divided into several portions. So if you know the mean of your distribution, and if you know the standard deviation, and if you know for sure that your distribution a is a normal distribution, then you can uh, easily say that 68% of the sample, like the sample performance, the sample mean, falls within one standard deviation from the mean. You can easily say that 95% 0.4 of your sample performance or mean would fall uh, within two standard deviation from the mean and like 98% within three standard deviations from the mean. So you remember that I talked about standard score. Specifically, I talked about z-score, and I said that a z-score or a standard score has is very useful in statistics because it gives you the opportunity to compare different scores from different scales, and also it enables you to compare the performance of a participant in your study to other participants. Um, Without normal distribution, without the concept of normal distribution, all these properties of normal distribution, basically you can't do anything with the z-score. Once you have the z-score, then you need to bring it into the uh, normal distribution and see like how one participant is doing compared to other participants, or how participants are doing in different tests with different scales. So it's very useful in a statistics. I don't need to emphasize it more. And it's basically normal distribution and Gaussian distribution is the kind of building block of statistics, is very, very important. Basically, everywhere we go, is the concept of the normal distribution is always used. So I don't need to emphasize it anymore. Then we go to uh, null hypothesis and alternative hypothesis. Remember, I told you that we have population, we have sample. You go to your population, you select some people through probability sampling, random sampling, and you create a sample. And then the the thing is that you definitely have a prediction before you start your research project. There is a research question in your mind, you're going to work on it. So there, that comes with a prediction. So uh, think about a treatment you're going to deliver. Uh, you should have a prediction before you start your treatment. For example, the people with aphasia who have a music therapy will do better than those without. This type of prediction you have before you start your study is called alternative hypothesis or an experimental hypothesis. Some people call it an experimental hypothesis too. So an alternative hypothesis predicts a relationship between the variables in your research. So and hypothesis, whether it's null or alternative, comes always before the study. So you can't really have hypothesis after the study because you need to have predictions before you start your project. And then these predictions could come from previous research. There should be previous research on the topic you're working to. Basically, based on previous research, after you read several papers, you come up with your predictions, or your predictions could come out of your experience. For example, if you're working in a clinic or in a clinical context, then based on your experience over years, you might come up with predictions, and then you want to put these predictions to test in a research study. In order to test an alternative hypothesis, it must be possible for the predicted effects to occur or not to occur. So an alternative hypothesis is always tested against a null hypothesis. And most of the times, at least in our field, most of the time, a null hypothesis states that an experimenter or you as an experimental will not find the result he or she expects. So if in the example of people with aphasia, we say that a music therapy uh, could help people with aphasia perform better in their daily lives, uh, as this is the alternative hypothesis. Uh, a null hypothesis states that music therapy cannot have or cannot make any differences in people with aphasia in their daily lives. I'd like to talk about type 1 and type 2 errors in hypothesis significance testing, null hypothesis testing, and these are very much related to what I've just talked about. Uh, so we have two types of errors. Type 1 error occurs when your null hypothesis is in fact true, but you kind of reject the null hypothesis by chance. And type 1 error is denoted by alpha level. So, for example, if you have an alpha level of 0.05 as your uh, decision criterion, that means that you could be only wrong for like 5%. However, in type 2 error, your null hypothesis is wrong and you need to accept your experimental or alternative hypothesis, but you kind of uh, fail to reject the null hypothesis. So uh, basically, there is a difference, there is an effect in your experiment, but you kind of fail to reject the null hypothesis and you can't show the effect. And this is denoted by beta. Usually type 1 and type 2 errors happen due to several reasons during the research process. For example, if there are many variables in your study and you couldn't control them properly, I mean, they could intervene, sneak in, and then uh, change the patterns in your study, which could result in like a type 1 error, which is also called false positive. On the other hand, for type 2 error, which is called also sometimes a false negative, a if you have a small sample size and like type 1 error if you haven't controlled many variables, so you could see a type 2 error. There are two types of research design. There are many different types of research design. I shouldn't say just two types of research design, but for our uh, for our presentation, for our seminar, we're just going to focus on these two types. So there is a within subject and between subject design. In the between subject design, as you could see here, we have two groups, and in each group, we have different participants. For example, if we are looking at the effect of aphasia type, we need to have two different groups, like a people with fluent aphasia and people with non-fluent aphasia, and we will compare them. So this is a between subject design. However, there is another design which is called within subject design. So in the within subject design, we are testing the same participants over time. Like we have two or three types of treatment, and then we start with one treatment and test them. We start with the second treatment and test them, and we start with a third treatment and test them. So it's the same type of participants in the design or in the research process. So depending on what type of design we have in our study, we need to see what type of a statistical test we need to use. So it's very important before doing the statistical analysis, it's very important to know what type of design you've had in your research. Otherwise, you can't select the right statistical test. So if it's between subject design, you need to select a special type of test. On the other hand, if it's a within subject design, you need to select a different set of statistical tests because all of the statistical tests are kind of designed based on on the assumptions within each of these designs. So it's very important to know what type of design you've had and then proceed with the right uh, statistical analysis. Well, when it comes to the statistical tests themselves, usually we kind of classify the test into two types, parametric types and non-parametric types. So the parametric tests are usually the default. Most of the times we want to go with the parametric tests because they're more powerful than the non-parametric tests. But it we can't really proceed with them always because they have certain assumptions. And if these assumptions are not met, uh, we need to move on with the non-parametric version. So what are these assumptions? So if the distribution of our dependent variable is normal, we can proceed with the parametric test. If it's not normal, then we need to use the non-parametric test. If the type of dependent variable is continuous, we can move on with the parametric test. However, if our dependent variable is not continuous, is either ordinal or nominal, we can't really use a parametric test. So we need to use a non-parametric test. So depending on the type of central tendency measure we want to use in the test, whether it's mean or median, then we have to select between parametric or non-parametric tests. So when it comes to uh, the uh, variability measure, the assumed variance of the sample in the parametric test is homogeneity. If you want to use a parametric test, the variance among the groups within the group, it should be homogeneous. But if this assumption is not met and you have like two groups where the variance is not homogeneous, then you need to stick to the non-parametric test. So once we start talking about a statistical test, we explicitly talk about the assumptions, and then we'll talk about both parametric tests and non-parametric tests. So uh, this was just a short, very, very short presentation on what a parametric test is and what a non-parametric test is, and then when we could move on with the parametric test, and then when we could do non-parametric testing. So with this slide, we come to the end of this session. I hope that it was useful. So at the end of this session, I expect you to know what different types of variables we have in our research, what is the meaning of normal distribution and how we can apply it in our research, what are the hypotheses in your research, and uh, what are the steps we need to take in hypothesis testing, what are the errors in our research, uh, what what factors kind of cause these errors. Uh, I need, I expect you to know the research designs and also the two types of statistical tests. So if you have any questions, please uh, stay in touch with me. Write to me at my email. Uh, and yeah, see you next session. Bye bye.